What we have in front of us is a diagram of a triangle where I'm given two angles and a side and asked to find a missing side of this triangle. Now this triangle is not a right triangle, so the normal laws of right triangle trig don't apply. The sine, the cosine, the tangent ratios I can't use at this point. If I wanted to solve this, I can eventually use those rules if I drop an altitude in and then create a right triangle. Then I could use a sine ratio to find the height. Once I have that height, I could take and use the angle of 26 to again use a sine ratio to find the missing value x. But that takes two steps, and it would be great if we could do it in one. So what I'm going to do is I'm going to go through a proof, if you will, as to how to find that value given two angles and a side, but only using one formula. So I'm going to draw in this blank figure the sides and angles. I'm going to circle what's given. And now what I want to do is I want to use all this given information to find a value of A in general. All right, now what we have to do in order to accomplish this is actually repeat what we did in the last problem, but in terms of any unknown values. So I'm going to drop in a height. And given the values that I know, I can say that the sine of A is equal to the opposite, which is h in this case, over the hypotenuse, which is c. And I can also say then the sine of angle C is equal to the opposite h over the hypotenuse A. Well, in both of these, I have the value of h. So what I'm going to do is isolate that. So I have C sine A is equal to h, but I also have h is equal to A sine C. I can set these two equal by substitution and say A sine C is equal to C sine A. And doing a little division here, I can say that the side C over the sine of C is equal to the side A over the sine of angle A. And that brings us upon a very important rule. And that rule is called the law of sines. It says if you take any side and the sine of its opposite angle, that's equal to another side over its opposite angle. And I can do that for any three sides on the triangle. Now, likewise, let's put numbers in here. If I said all these are equivalent to 1/3, if I took all their reciprocals, then they would all be equal to 3. So I can say this either way. I can say A over sine A is equal to B over sine B, or sine A over A is equal to sine B over B, whatever works the best. Now, again, we call this the law of sines, and this is typically used when you're given two consecutive angles and a side, or two sides and an angle. Let's do the problem we just tried to work out in two steps, but now in one. Notice I'm given two angles and a side, and I'm looking for the opposite angle. So if I can just take and say, well, that x value over the sine of its opposite angle is equal to the side of 8 over the sine of its opposite angle, 26. And then we're just going to plug that into our calculator. Now, it may be easier for you to do it this way and isolate the x value and say 8 sine 55 over sine 26. And when you pop that in your calculator, you need to make sure you're in degree mode. And the final answer is going to be 14.94-ish, right around there. Okay? So again, really important that you have an angle and its opposite side and another angle and its opposite side. So let's take a look at this problem. It's going to say solve the triangle ABC given the following values. Well, what you need to do in this case is you need to actually draw the triangle out. Doesn't really matter where you put stuff at this point. So here's A, B, and C. And let's say this is 40, this is 80, and the side opposite is 16. Well, this isn't the same situation we had before. Notice we don't have a side and its opposite angle. And we're looking for other sides and their opposite angles, but we don't have those either. However, since this is a triangle, we know that in triangles they add up to 180 degrees. We can say I have 120 degrees already used, so this angle C has got to be 60. And now notice, I have an angle and its opposite side, and now I have two other angles and I can find their opposite sides. So I'm going to go ahead and do that. I will first solve for side B. So I know B over the sine of 80 degrees is equal to 16 over the sine of 60 degrees. And again, I will take and multiply the sine of 80 to both sides. So I have 16 sine 80 over the sine of 60. And now I'll go ahead and plug that into my calculator, again making sure I'm in degree mode. So this will give me B is equal to approximately 18.19. All right. And I'll just fill this in here. And then finally we have to find the missing side A. So A over the sine of its opposite angle, which is 40 degrees, is equal to, now I have a couple of options. I can use a ratio with B in it. However, when we got this answer of 18.19, that's kind of a round off answer. I'm going to use exactly what's given to me. So I'm going to use the 16 again since that was pretty much exact. And then I'm going to use the angle value for C again, which is the sine of 60, because 60 was an exact value. I can just subtract 120 from 180, and I know I'm exactly at 60 and don't need a calculator round off. So I have A then is equal to 16 sine 40 over sine of 60. Go to my calculator again, making sure I'm in degree mode. And in this case, I'm going to get A is equal to 11.87 roughly. So in solving the triangle, what I was missing was the angle C, which I found out was 60 degrees, the side B, which I found out was 18.19, and the sine A, which I found out was 11.87. So the triangle is solved for. Now I have all missing sides and angles. So let's do another one. In this case, again, I have triangle ABC. So we'll draw in A, B, C. Put 25 as my angle measure. Side B is 21.1, and side C is 16.5. Now, in this case, I'm noticing that we have an issue in that I can't find this opposite side. But notice I'm not asked to solve the triangle, I'm asked to find the area of a triangle. Now, the book is going to give you a formula in order to do this, which I'm not necessarily a fan of. I would rather you just use common sense and say, well, listen, if I want to find the area of a triangle, I need 1/2 base times height. Right? So if I know that, then all I really do is need the height of this triangle. And I know my height can be found by dropping an altitude in. So all I need to do is find this height. Well, fortunately, I have a hypotenuse, an angle, and I just need its opposite side. So what I'm going to do is I'm just going to find h. All right, I'll take the sine of 25 is equal to the opposite side, which is h, over the hypotenuse, which is 16.5. H then is equal to 16.5 times the sine of 25. And I can get that in my calculator. So in this case, the height is roughly 6.97. And then if I want to find the area, I take 1/2 my base, which in this case is the 21.1, times my height, which I just calculated, is 6.97, and I have a value for area of approximately 73.5 and units squared or whatever. All right. So that's probably the easiest way to calculate area, and that's the way I'd probably use. So we have an application problem where we've been told we have an antenna standing straight up and then 2 cables attached to the ground on either side. And it says the longer of those 2 cables is 300 and the shorter of those 2 cables is 270. It says the longer cable makes an angle of 48 degrees with the ground. Now we're going to assume that this antenna is straight up and down on the ground. And we want to find the acute angle that the shorter length makes with the ground. So I'm going to call that theta. Notice my answers are up here. And then what we're going to do is we're going to find the distance on the ground between the 2 cables. So notice I have a side and its opposite angle and another side and its opposite angle. So this is all set up for the law of sines. And we know that we can take and find the sine of the unknown theta over its opposite side will equal the sine of 48 over its opposite side. Now in this case, the sine of theta is going to be equal to 300 times the sine of 48 over 270. Now I've got to go to my calculator and calculate theta using an inverse sine. So I take the inverse sine of 300 sine 48 over 270, making sure once again I'm in degree mode. And after plugging that in, I get roughly 55.66 degrees. For this angle. Now the last thing I wanted to do is I wanted to find the distance along the ground. Well, I know if theta is 55.66 degrees, I simply take and subtract 48 and 55.66 from 180 to get my missing angle. And that missing angle is going to be approximately 76.34 degrees. And that guy's right here. So again, I need to find the missing side along the bottom. So in this case, I'll take that missing side, let's call it x. Put that over the sine of its opposite angle, which we just determined was 76.34 degrees. Set that equal to, I'm going to use the original angle given to me of 48 degrees and its opposite side, which was 270. And then we can find x from here in the way we've found x all day long. And x is approximately 353.04, roughly. So that's all we have today. Here are the questions to answer, and we'll see you tomorrow.